Dear students, today I am going to discuss about the topic biosensor. Is how biosensor assay is used for assessing ligand receptor interaction. Biosensor is actually an analytical tool, an analytical device that can be used for the detection of an analyte that combines a biological component with a physicochemical detector. So when we compare with any other presently existing diagnostic tools or diagnostic device, sensors are advanced in the conditions of selectivity as well as sensitivity. So these are self-contained integrated device that can be or that is actually capable of providing specific qualitative or semi-quantitative analytical information using a biological recognition system or biological recognition element, which is in direct spatial contact with the transduction element. And this is the definition proposed by IUPAC in 1998. So from this definition, we can say that biosensors are bioanalytical systems where an enzyme electrode uh, can be used in the form of a biosensor. So a sensor that integrates the biological element with a physicochemical transducer to produce an electronic signal proportional to a single analyte, which is then conveyed to a detector. The application of these biosensors mainly include checking of ecological pollution control in agriculture field, as well as in food industries, in diagnostic laboratories. And the main features of biosensors are stability, cost, sensitivity, and reproducibility. Currently, biosensor can be defined as the integrates as a sensor that can integrate a biological element with a physicochemical transducer to produce an electric signals. And Leonard C. Clark Jr., who is recognized as the father of biosensor. Now I'm coming to the main components of the biosensor. So a biosensor, uh, here you will see that the biosensor is an analytical device which is used to determine the desired molecule. So this is the desired molecule that is present with so many other biomolecules, and this mixture is actually known as a biosample. It may be the urine sample, blood sample, sputum, whatever it is. So mixture of molecules are there, where from we have to pick the desired molecule. And who is picking the desired molecule here? It is the bioreceptor that is actually picking the desired molecule from the mixture of the molecules, mixture of the biomolecules. Now, after receiving this or after identifying this desired molecule. The bioreceptor is actually interacting with the desired biomolecule, and due to this interaction between the receptor and the ligand or the desired molecule, the method is actually known as recognition of the molecule. Then this interaction will develop some signal, and that signal will be conveyed, will be transferred to a different section that is known as transducer. And this particular method is known as transduction. Now the transducer will send the signal that has been received from the bioreceptor to a different component that is known as signal processing unit. So there the signal will be processed. It may be amplified. In some cases, if the signal is very poor, it should pass through an amplifier. The amplifier is only just enhancing the signal, and that enhanced amplified processed signal will be displayed in a display unit. So this is the general form of a typical biosensor. Here are the components. So this block diagram of the biosensor includes three different sections, namely the sensor part, the transducer part. Sensor part means who is recognizing it, is the bioreceptor part, the transducer part, and the measurable signal as well as the detector. And that particular measurable signal or processing unit is actually processing in the form of current, or in the form which is associated with electrons. So in the first section or the first segment, the recognition part of the sensor, it is responsive to biological part. The second segment, which is the detector part, that changes the resulting signal from the contact of the analyte, and for the results it displays in an accessible way. So the final section that comprises of an amplifier, which is known as signal conditioning circuit, and later on a display unit as well as a processor. So these are the major components of sensor. Now, what are the analytes? Analyte means what we are trying to detect, what we want to detect. Here in case of biosensor, the analytes or the ligands, that may be of different kinds. That may be a protein, that may be a toxin, that may be a peptide, vitamins, sugars, metal ions, so many things that are related to biology or biological system. The second, here you have seen that here in case of a toxin, cholera toxin can be detected. In case of sugar, glucose can be detected. In case of diabetic patients, glucose biosensor is used for the diabetic patient. Now, what are the elements of biosensors? So the bioreceptor part, that is the sensor part, and the sensor part, or the bioreceptor part, contains different components. If we are trying to identify the antigen, then the bioreceptor should be an antibody specific to that antigen. If it is a substrate, then the bioreceptor part should be an enzyme specific to that substrate. Whereas it may be a cell, it may be nucleic acid. And the transducer part, there are different units. If we are developing an optical biosensor, so the transducer should be optical. Means there we have to use the techniques like absorption, fluorescence, interference, like that. So depending on the nature of transduction, the parts of the components of the transducer should be optical, electrochemical, mass-based, temperature-based, electric or magnetic-based. So if the metal ion that has the dielectric properties or that will develop some current or voltage, then we should use the electric or magnetic transduction. If it is a temperature based, means temperature is raised, then we have to use some uh, thermometric property, that should be thermometric biosensor. If it will develop, it will develop mass change, then we have to use some piezoelectric crystal there. If it is developing some electrochemical reactions, then we can use potentiometric, amperometric, conductometric transduction. So these are the types of transducer we can use as an element of biosensor. Now, what are the bioreceptors? As I said, that antibody, enzyme, cell, or else MIC or polymeric hydrogels, all simple polymers that have specificity can be used here. Means here the detection unit or the recognition unit that is actually functioning as a bioreceptor. Means how do we specifically recognize the analyte? That is our motto. And on that basis, we have to utilize the bioreceptor component in the form of antibody, enzyme, cell, or polymers or hydrogel that should have competitive binding or specific binding towards it. Next, I'm coming to the signal part. Means how you can detect what type of interaction has happened. So here, specific recognition system should be there because the detector are often immobilized into a solid surface. So under this immobilized conditions, it would sufficiently detect the biological molecule that is present in very trace amount, very minute quantity into the cell in the form of an analyte. So the common signaling principles are optical in the form of infrared, in the form of absorption, in the form of surface plasma resonance, or it may be electrical, it may be electromechanical, it may be electrochemical, it may be thermal, magnetic, pressure, like that. So on that basis, we have to select the transducer, we have to select the bioreceptor accordingly, and usually a specific enzyme or preferred biological material is deactivated by some of the usual methods, and the deactivated biological material is in near contact to the transducer. The analyte connects to the biological object to set a clear analyte, which in turn gives the electronic reaction that can be calculated in some, for example, the analyte is changed to a device which may be connected to the discharge of gas, or maybe production of heat, or maybe production of ions or hydrogen ions. So in this, the transducer can alter the device that is linked to it and convert into electrical signals. And these converted electrical signals can be changed and be calculated. So the analyte diffuses from the solution to the surface of the biosensor. Then the analyte reacts specifically and efficiently with the bioreactor part of the sensor, or the sensor part of the biosensor. And this reactions changes some physicochemical properties of the transducer surface. This signal leads to change in the optical electrical properties of the transducer surface. And this change in the optical electronic or optoelectronic properties is measured or else converted into an electrical signal which can be detected and displayed to the unit. Now, working of a biosensor is actually the electrical signals of the transducer that is frequently low and overlay upon a fairly high vessel. So, in common practice, a signal processing unit should be included here, deducting a position baseline signal obtained from a related transducer without any biocatalyst covering, and the comparatively slow characters of the biosensor reaction significantly eases the electrical noise filtration issue. In this stage, the direct output will be an analog signal, however, it is altered into digital form and accepted to a microprocessor phase where the information is progressed, influenced to preferred units, and then the output, to a data store. So the basic characteristics of the biosensor is that selectivity, sensitivity, linearity, response time, and reproducibility. So these are the basic characteristics of a biosensor. Now I'm coming to the types of biosensors. The different type of biosensors are classified based on the sensor device as well as the biological material that is discussed here in the form of electrochemical biosensor, amperometric biosensor, potentiometric biosensor, impedimetric biosensor, voltammetric biosensors. So these are the 5 different types of biosensor, and there are some subtypes also. Likewise, you can see here electrochemicals biosensor can be classified into 4 subtypes as amperometric, potentiometric, impedimetric, voltammetric. So these are the types of biosensors. Now I'm coming to the application part. Biosensor can be applied in different fields, in diverse fields, like in common healthcare checking, metabolites measurement, screening for the sickness, insulin treatment, clinical psychotherapy, diagnosis of a particular disease, soil testing for the agricultural purposes, veterinary applications, food quality testing, toxin testing in case of defense, drug improvement and offense detection, and also in ecological pollution detection. So environmental monitoring. So everywhere we can use biosensor. That's all.